there's a table to essentially talk about equipment which cannot be handled by the approach we just discussed. Yeah.
How do you get FP from that graph? What point do you locate?
So FP you actually get just from that equation.
I mean, not FP, FM.
FM you just so once you have your identifier, you look at this identifier, look at your dot, you just read the value. Like number 10 is 1. Number 9 is 11.
Oh, okay.
Right? Just read. As I'm saying, this is sort of a good way of presenting data, but some people might think of it as far too complicated way of presenting data. At the end of the day, costing is all about looking at the prior data and using that data, but of course you have to construct some sort of a framework to do that. Right? In some sense, it's all curve fitting. You're trying to fit the data to a simplistic representation and then use that to calculate cost. So it's all interpolation based on prior knowledge. Okay, so all costing is interpolation based on prior knowledge. Okay, so this is here I'm listing some of the sort of exceptions. So you can see that compressors and blowers without drives, the bare module cost is CP naught FPM, where, well, that's actually the German equation anyway, so that's nothing new there. But anyway, but let's look at, like for instance, let's look at fired heaters and furnaces. So for fired heaters and furnaces, the bare module cost is CP naught FPM, and FPM, of course, you can estimate as B1 plus B2 FMFP times another FP times FT, where FP can be calculated from this equation, where delta T is the temperature difference. Most of these, I think, you will not encounter as much. One that is a good one, important one is sieve trays, valve trays, and demister pads, because you will frequently use this in distillation columns. Okay? So there, for sieve trays, valve trays, and demister pads, you have to use this equation for bare module cost, Cp naught, which of course you can calculate, right, as using C1, C2, C3. N is the number of plates, which is obvious. F bare module is the bare module factor, which you already know. But then you have an extra factor multiplying called FQ. And FQ you calculate from this equation. Okay. Now, unfortunately, I cannot give you any good reason of where this equation is really coming from or why it is significant. Except that you can see this number will be between 0.5 and 1. So there's less number of trays. When there's a lot of trays, we just get 1 there. But for less number of trays, there's an extra correction factor. All right. So this is some of the equipment where FPM is directly given. So for some of the equipment, you will find FPM directly given. So this essentially is B1 plus B2 FMFP, right? Yeah.
So like, who collected all this data and made all these relationships? So you have like buy these data sets from people?
Yeah.
Or, like,
Yeah. There are entire companies whose entire existence is based on doing costing for people. They have their databases. Of course, the book has a pretty big database, but this database is minuscule compared to what a company would have.
So like, who's collected all this data? Is like Dow, like the original?
You have to pay money, yeah. Of course, companies will have their own data, and then companies will buy data from other companies. Eventually, just like economic data, it costs a lot of money to get economic data. Like if you want to figure out how the cost of certain products has changed, or what the forecasts are, I mean, I know that firsthand because I have to do a lot of this stuff, or a lot of things that we do, or some of the research I do, because a lot of research I do is all translational research. We want to make sure what we are doing is highly relevant to the demands for the society. So we have to sometimes pay money to get these reports, which tell you what the current numbers are. What is the current market for glaucoma? What is the current market for a specific drug like timolol? It actually costs a lot of money to get data like this. Yeah, companies pay money to collect the data, and then they have the data, and somebody who needs the data will approach them, and they will sell. Reports, economic reports, sells for thousands of dollars. All essentially data. All right, so these are the equipment for which, like I said, FBM is directly given to you, so you don't have that equation B1 plus B2 FMFP. All right, so that's let's see, how much time, right?
We're almost out.
I have a lot of time. Yeah. So, do you have any questions about what we've talked about so far? No? Is it because you're just too bored? Or is it because you understand everything so well?
On a test, we could just have to wing it, wouldn't we?
You have to just do what?
Wing it.
What does that mean, wing it?
Just walk in there and just hope you can find everything in time, pretty much.
Oh, no, I'm not that mean. I don't like torturing people like that. I like torturing by making you use your brain. I don't like torturing people to look for data at the exam. So you will not have questions from this part of the course in an exam. I will not ask you to do cost estimation in an exam. What I normally do is I do a quiz, but I make it a take-home quiz. So we can talk about that. Now I am okay with, so there are only two options. Either everybody uses cap cost to do that quiz, or nobody uses cap cost and everybody uses these equations.
Equations.
Okay, so I guess most of you don't have the book, so you don't have access to cap cost. And I'm okay with that. So I will give you a take-home quiz, and that will take a fair bit of time. But I think it's important. Actually, I prefer that instead of using cap cost, because if you do cap cost, just put in numbers. I think it's good, because I told you, it's not going to be the exam. That quiz is one time where you actually are forced to look at everything and just do this. Because you all may think all this is boring and not useful. Actually, you were telling me, somebody was saying how useful it is because of an internship in a company. How many of you have been costing or been exposed to costing in internship? Again, would one of you maybe explain how important it was or how useful it was, so the rest of the students kind of see it's really useful? Yeah.
Okay, so I worked at a pilot plant where we were testing out a process, and we had to figure out what the cost of scaling up would be, so that was very important in that project.
Okay, all right, very good. Anybody else? You want to talk about your experience? Yeah?
So we use costing more for Six Sigma projects, assessing how improving the plant would save the company money rather than buying.
Okay, great. So we'll talk about those examples too later. But so yeah, and I think we discussed this a little bit right in the beginning. Most of you will probably never have to cost entire plants. But I can certainly assure you, most of you who end up in industry, at some point in time, will have to cost something. It could be something like a new heat exchanger, just to figure out whether it's time to replace it. It could be something like just costing and insulation. But you will almost certainly have to do some sort of costing at some point in time. So it's good, and in any case, even if you don't have to, clearly, plants exist to make money, right? Chemical industry exists to make money, and that's not a bad thing, because that's the only way they can employ people, right? So I also tell students that once you go, so you certainly have a PFD to look at what your plant does, right? But you should also look at the financial report of your company, because it's very important to know what the company considers important. So typically the financial report of the company tells you a lot about what it values and what it doesn't value. And so it's very important, very important if you really want to stay in that company for long periods of time and really progress, it's good to really understand the money flow in the company. What are the products that are really making money? What are the products that are kind of just there because, well, they just don't want to get rid of it just right now? So yeah, from that perspective too, it's just important to understand the concept of money, also in your personal life, right? It's just good to understand what money is, how it moves, what its value is, how you analyze. And so from that perspective, I think when you start working for a company, even if you never have to do costing, it's always good to know these issues at least a little bit. All right, so at this stage, does everybody feel comfortable that if I give you a costing problem, you can kind of look at the book, find all the tables, and just get the numbers, right? Let's go over what do we need. We need K1, K2, K3, right? That's the first thing. Then we have CP naught. Then we need B1, B2, FM, FP, right? B1, B2 we'll get from tables. FP, to get FP we need C1, C2, C3, right? And of course we're left to find the FM. and FM we can get from the charts, and then we are in a place where we can calculate costs, bare module cost, except for some equipment where the tables will tell you there are unique ways of doing it, in which case the tables will also tell you the unique ways. Like for some equipment, there's directly FPM. The FPM is directly there, so you don't have to think about D1, D2, FM, and FP, because you can directly use FPM. Okay? Because D1 plus D1, P1 plus FM, FP, P2 is actually equal to PM. Sorry, FPM. FPM is the bare module correction factor. Okay. All right, good. So that's great. And so then what you do is, if you want to calculate the total cost of the equipment of the plant, what you do is you add up all the costs of the equipment, right? You do this calculation for every equipment, you just add it all up, and you're kind of done. You know the total cost of the equipment, of the plant. Now there is an intermediate way. So you can see the really simple one is block estimate, right, or the order of magnitude estimate. Now you're doing a study estimate. This is something in between called Lang factor. The way Lang factor works is, you say, you know what, I'm not going to worry about, I'm only going to worry about my equipment costs. I'm not going to worry about all these other indirect costs. I'm just going to find out the cost of the equipment, add it all up, and then multiply by the Lang factor. So the idea is that these extra costs you incur, there's not too much variability from equipment to equipment. So rather than looking at this D1 plus B2 FM FT for each and every one, what you do is you simply add up the cost of each equipment and then multiply it by the common factor. And that's called F-Lang. And that F-Lang, as you would expect, will likely be between 3 and 4, right? Because that's what we said. We said the costs are always between 3 and 4. But the important thing is that this, what you multiply to get, so the CTM is the total module cost. The total module cost, remember, is bare module cost plus contingency and fee. But what you are multiplying the Lang factor by is CPI, and CPI is the cost of the equipment at the actual conditions. So it's not CP naught. Okay? So you have to figure out the cost of the equipment, whatever the conditions are, and add them all up, and then essentially from there figure out the total module cost by multiplying by the Lang factor. So it's something in between doing the block estimate, the order of magnitude estimate, and the study estimate. Okay, so all of this, of course, will give you the cost at some point in time. What point in time will it give you the cost?
Depends on the data.
Depends on the data, right? Based on whenever the tables were actually done. So likely it will be not today's date. So then you have to finally, whatever you calculate, you have to scale that up to present time, and you do that by steps. Okay, so first you calculate the costs at the time corresponding to all the data, and then you scale that up to get to present time by using steps. So that's pretty much it, except as I said, if you want to go from bare module cost to total module cost, you add contingency and fee, which is 18% of the costs. And if you want to do a grassroots cost is the total module cost, which is the first you sum up the bare module costs, then you take extra 18% for contingency and fee, and then you add up the grassroots cost, which are 50% of the bare module cost at zero condition, at the base condition. Okay? So you can see the grassroots cost actually could be quite substantial, because you need a lot of infrastructure. If there's nothing there, you need a lot of supporting infrastructure. That could be as much as 50% almost of the cost of the equipment at the base condition. Okay, so that's really all there is to capital costs. Any questions? Yeah.
I guess for the grassroots, is that more in the sense that you're hooking up to county, trying to get like county equipment, or what if you like generate your own power plant?
But then you have to spend money for all that facilities that will generate the power, right? So either way you have to pay. Also, it's not just the utilities, it's also the building infrastructure, right? You probably have to start some restaurants. You may actually need a hospital. So there's just a lot of supporting infrastructure you will need right around, right? Okay. Any other question? Any comments or?
So when you mean grassroots, you mean kind of like in that sense, going and building in the middle of a jungle somewhere?
Pretty much, yes. Not in the middle of jungle because then you have to remove the trees. I don't like that. But
You don't like trees?
I don't like removing trees.
Oh, okay. So you like trees?
I love trees. Trees are good. All right. I do see a lot of kind of bored faces. What do I do to make this whole thing more exciting? Sorry?
It's a little hard to do that.
You can dance and sing it.
Sorry?
Dance and sing.
You don't want me to do that. I think I'm a great singer. I think I'm ahead of my time. People just don't appreciate my style. Sorry?
I'm sure that's the case.
Of course it's the case. Would I lie to you? Yeah.
I think once a month on Fridays we should have a lecture somewhere other than the classroom, to spice it up.
Where?
Outside.
Maybe out at the bar or something.
Like a bar. Okay, there are a few problems with that.
Maybe that's falling.
But I'm going to start with the most obvious one. If you're at a bar, would you rather listen to me or would you rather have a drink? I don't think I can compete with that. All right. Yes.
Do you have any like industry connections where you could get them to come in and maybe do a guest lecture on something?
We can do that. We can try that. Actually, no, I don't really need industry connections. During the career fair, I will ask Cynthia if she can have some of the chemical. So that's a great idea. We have done that in the past. There was a student once who came. He was a student there. Now he's working I think in Extras. So he came and he talked about how they were actually using costing just at that moment to analyze what to do with an exhaust stream. So there was an exhaust, and they're trying to figure out whether to extract heat from that exhaust, because the exhaust was at a very high temperature. And they were trying to do economic analysis to figure out whether to extract heat or just let it go. So yeah, I will ask Cynthia. That's a great idea, if you can find somebody like that. Any other questions, comments, points? Yes?
I think you should have the slides have those like transitions where like.
You want to work on that for me?
You wanna pay me?
Sorry?
You wanna pay me?
I don't get paid any extra for this job. You don't want to help your professor. All right. What else? Okay, I think you got the idea, right? So basically, all it is you look at the table, and that's all I want you to understand. That costing is very, very important. Okay. And the way to do costing is to figure out where you're going to get the data and use it. And right now you're lucky because your book has all the data. But these important words, some words you have to understand. The bare module cost is an important word. What is the ratio of bare module cost to the actual cost of the equipment? Roughly 3 to 4. That's an important thing to remember. And of course, what is FM? What is FE? What takes into account material of construction? What takes into account pressure? And how to put it all together? I mean, and I think you kind of are there. So I think we can move on to an example. So this is the example we're going to do. We're actually not going to do that. Well, maybe we will. At least maybe let's just do one of these. So this is a process flow diagram for just a distillation column. Right? So T101 means it's a tower in zone 1, first tower. Of course, it's a distillation column. There's a feed coming in, right? There are streams coming from the bottom and the top, but of course there's a reflux. And then you have product tube, of course, and then you have, so there are 3 heat exchangers, overhead condenser, reboiler, and a product cooler. Product is a very high temperature, so you cool it. Those 2 are obvious, every heat exchanger will have those. Then reflux pumps, you want to put the reflux back, so you have to use the pump. What does A/B means? There's a backup, or they're in parallel. You can see that they are not in parallel, that means it's a backup. That's just an aromatic column. And then the reflux drop. Okay, so these are the different equipment numbers. The capacities are given here, materials of construction are given here, and pressure is given here. So let's go ahead and start costing